Okay, the first thing you have to do in number 7 is find the actual perpendicular height because they give you the slant height. And you don't want the 10 because that's kind of slanted and crooked. So you see that there's a triangle there, so you do Pythagorean theorem. To solve for the actual height. X squared will equal 64, so the height must have been 8. So now I can change the height to 8, and that's the number I really want, not the 10. Since it's pointy, volume equals big B times h divided by 3. Volume is the area of the base, which in this case is a circle. So it's pi r squared. The radius was 6. So 6 squared is 36. 36 pi times the height of 8. 36 times 8 divided by 3 is 96. I'm going to leave the pi there because up here it said exact. And exact means do not calculate pi to the nearest tenth or hundredth or any decimal point. Leave the pi in it. And we're talking about volume, so I'm talking about meters cubed. In the next problem, they show you that the diameter of the sphere is 17, but you don't want the diameter. You usually want to work with the radius. So 17 divided by 2 is a radius of 8.5. You see in the problem highlighted there that it wants you to round off to the nearest tenth, which means don't leave pi in your answer. It means you want to calculate 3.14 or hit the pi button. So we have 4/3 times pi, and the radius was 8.5 cubed. So that's 4/3 pi r cubed. So when you multiply the 4 times pi times 8.5 times 8.5 times 8.5 and divide all of that by 3, you end up with 2,572.4 meters cubed. The next problem does give you the radius, so you don't have to convert diameter to radius. You are going to use the 3 millimeters as your radius. This time it says exact, so I am going to leave pi in my answer. 4/3 pi r cubed. And the radius was 3, so I leave the 3 there. And when you multiply 4 by 3 times 3 times 3 and divide it by 3, you get 36, and I drop the pi down because I want it in terms of pi. In the next problem, I drew a box of chocolate, and the box is 1 foot tall, but I converted it immediately to inches because I noticed that the rest of the problem was in inches. So I made it 12 inches instead of 1 foot. It also already calculated the base, the bottom of the box, to be 35 square inches. So this has already been big B 35 for me. I don't have to figure out any shape of the bottom. It's already 35. If volume is big B times h, and they already gave me big B, and I know that the height is 12, this would have to be my answer. The first one, the number 1, is not in inches yet. It kept it as feet. Choice C says 1/3, and there's nothing pointy going on. And 35 squared, well, area was already squared, so you don't square it again. Okay, now you're going to do problems 11, 12, 13, 14, and 15 on your own, and I'll provide some hints for you on the screen. The first one, it gives you V, the volume. It gives you big B, and we know it's divided by 3 because it's pointy, so solve for h. Multiply both sides by 3 to start. A hemisphere is really just a sphere cut in half. So the formula you're seeing there is for a sphere. It's in the back of your green book, and it's also going to be given to you on the Regents, 4/3 pi r cubed. So if you can calculate the volume of what would be a total sphere, and then figure out what would be the hemisphere. Look closely at this one. Volume of a pyramid is the area of the base, big B, times the height divided by 3. But the problem is here you don't know the height. Just like in one of those earlier problems, if this is 8, well, the bottom of this little triangle inside would be 4 because it starts in the center. So that's 4. The slant height is 10. So Pythagorean theorem, a squared plus 4 squared equals 10 squared. That will give you the height, then plug it into the V equals big B times h over 3. Play this video back if you need to hear that again. You'll notice that there's an equilateral triangle for a base here. If one side's 12, the way the markings are showing, apparently they're all 12. So maybe draw an equilateral triangle somewhere off in the distance and see if you can figure out what the height of that would be, what the base would be, and try to find the area of that. Then multiply it by the height of the pyramid 10, and then divide it by 3 because it's pointy. Again, play that back if you need to hear it again. This is a cone, but it's leaning over a little bit. But the height is still 5 because you can see the height is still perpendicular to the base. So normally cones look like this, but they can be shifted to one side. As long as you have a right angle, then this is your height. So again, the diameter is 6. Be careful. You want the radius. The volume is 1/3 pi r squared times the height, or pi r squared times the height divided by 3 because it's pointy. You're going to want to see two separate shapes here. You're going to want to see the rectangular prism on the bottom, sort of like the base of the whole thing. There's like a pyramid sitting on top of it. So then you have this pyramid with a rectangular base sitting on top of this. So it looks like I just detached it for a minute so you could see both shapes. And then the second issue with this is the pyramid has a height that you have to find with a slant height again, just like the other two problems before it. All the information is right here. So separate it and treat this like a multi-point question on the regions where you don't necessarily have to get the entire thing right if that's the goal. But if you can score a lot of points on this by separating the shapes and at least finding the volume of one and trying the other, get as many points on this problem as you can.